There are places on Earth where nature draws a hard line, where mountains don't just rise and they stop everything. Rivers don't cross them, ships don't climb them, trade doesn't pass through them. But here in China, that rule was broken. Not by carving a tunnel, not by going around, but by doing something that sounds completely impossible. They built a system that lifts entire cargo ships straight up a mountain. And not a few meters, but nearly 200 meters into the sky. What you're about to see isn't just engineering, it's a machine so powerful it rewrites how gravity is negotiated. But here's the real question. Lifting the ship isn't the hardest part. The real challenge is what had to be built before the first drop of water could even exist this high above the ground. The mountain doesn't welcome this idea, it resists it. Solid rock, thousands of years old, standing in the way like a wall that was never meant to be moved. So the first step isn't construction, it's destruction. Explosions tear through the silence, ripping open the mountain piece by piece. Dust clouds rise like storms as millions of tons of rock are forced out of existence. But even that is just preparation, because what they're about to build here isn't sitting on the mountain. It has to become part of it.
I'm now standing at a place where there was once nothing but solid mountain, and now a structure is about to rise here that will challenge the very rules of engineering across the world.
To lift something as massive as a cargo ship, you don't just need strength, you need absolute stability. And that starts underground. Deep below the surface, a massive pit is carved, not visible from above but critical to everything that follows. Steel frameworks are lowered into place, forming a skeleton that will anchor the entire structure. Every joint is tightened by hand, every cable locked into position, because even the smallest weakness here will multiply as the structure rises. Then comes the moment where everything changes. Concrete begins to flow, not poured, but injected like lifeblood into the mountain itself. It spreads into every crack, every gap, binding steel and stone into a single immovable mass. Day after day, the pit disappears, replaced by something far stronger than rock. This isn't a foundation anymore, it's an artificial extension of the mountain, designed to carry forces nature never intended. But the real challenge hasn't even started yet, because now they have to go vertical. A steel collar wraps around the core of the structure, not as decoration, but as a machine. This is the climbing factory, a system that doesn't just build upward, it lifts itself as it builds. Concrete is poured, the structure rises a few meters, and then the entire system climbs higher to repeat the process again, over and over, day and night. No pause, no reset.
If you look down, the ground is no longer visible. With every meter, the risk keeps increasing, and there's absolutely no room for error here.
From the outside, it looks like a tower growing into the sky. But inside, it's something else entirely. A hollow core runs through the center, a massive vertical chamber that will eventually hold a machine powerful enough to lift thousands of tons. Every centimeter of alignment matters. A tiny error at the base could become a catastrophic shift at the top. And yet, they keep climbing. 100 meters. The air changes, the wind is no longer just wind, it becomes a force pushing against the structure, testing every connection. Workers move carefully, each step deliberate, because up here there is no safety net that can truly save you. Only precision, only discipline. The towers begin to take shape, not one, but three, rising simultaneously from different points in the valley, like artificial cliffs being pulled out of the earth. From a distance, they don't look like buildings anymore. They look like something geological, as if the mountain itself is growing new peaks. But these aren't natural formations. They are machines in disguise.
These aren't just concrete towers. They form a track, a pathway along which an entire ship will travel upward. And when you're standing at this height, you realize just how dangerous it truly is.
Inside the structure, another system is forming. Steel beams interlock like a three-dimensional puzzle, creating a rigid frame that will guide the movement of something enormous. Every weld is tested, every segment inspected. There's no room for assumption here, because once this system is activated, failure is not an option. As the height increases, so does the complexity. Cranes begin climbing the towers themselves, lifting their own bodies higher, adapting to the structure they are helping create. It's a strange sight, machines building a structure that forces the machines to evolve as they go. And still, they climb. 150 meters. Now the valley below feels distant. The towers stand above the natural landscape, casting long shadows that stretch for kilometers. Up here, the scale becomes difficult to process. The workers look small, the machines look precise, and the structure feels unstoppable. But something is still missing because these towers alone don't solve the problem. They are only half the system. What connects them is where the real risk begins. Far below, in another part of the valley, massive steel sections are being assembled, not randomly, but as parts of something much larger. Each piece is designed to fit perfectly with the next, forming a continuous channel, not for vehicles, but for water. A river. That doesn't exist yet.
Imagine a river that doesn't flow on land but in the air, and ships travel across it. This isn't just engineering, it's the next level of imagination.
Then comes one of the most dangerous moments in the entire project, the first lift. A massive steel segment, weighing hundreds of tons, is slowly raised into the air, suspended by cables, controlled with extreme precision. The wind pushes against it, gravity pulls it down, and yet it rises, slowly, carefully. Every movement calculated. Because once it reaches the top, there is no second chance. It has to fit, high above the valley, where even the wind feels unstable. The first steel segment hovers in position. Suspended between sky and earth, it sways slightly. Not enough to panic, but enough to remind everyone watching that this entire operation exists on a razor's edge. Below it, nothing but air. Above it, nothing but expectation. Then, slowly, it begins to descend. Guided by signals measured in millimeters, the piece is lowered into place between two towering giants of concrete. For a brief moment, everything feels frozen. Machines pause, workers hold their breath, and then contact. A perfect connection. Not forced, not adjusted, just aligned. In that instant, something shifts. This is no longer a construction site, it becomes a system, a structure that is starting to behave like a single organism.
Now standing at a height of 200 meters, and beneath me there's nothing but air. And here, this steel section you're looking at, it's not just a bridge, it's the floor of a river that hasn't even been born yet.
But one segment isn't enough. The process repeats again and again. Each section lifted into the sky, stitched into place with fire and precision. Welding sparks scatter into the void, briefly illuminating the scale of what's being built. Slowly, almost silently, the gap between the towers begins to disappear. A bridge forms, but not a normal bridge. This one has to hold something far heavier than traffic. It has to carry water, millions of liters of it, and more importantly, the moving mass of cargo ships. That means the structure can't just be strong, it has to be flexible, because steel expands, contracts, moves, and if it doesn't, it breaks. Deep within the joints, hidden from sight, expansion systems are installed, mechanisms that allow the entire structure to breathe, to shift slightly under temperature and pressure without tearing itself apart. It's a quiet detail, but without it, the entire system would fail. Then comes sealing. A high-tech membrane is layered across the steel surface, a barrier so precise even a single flaw could cause a leak. And up here, 200 meters above the ground, a leak isn't just water loss, it's catastrophic.
If even a single drop leaks from here, it's not just a water issue. The entire system could be compromised. That's why every inch is being tested again and again.
Section by section, the channel is completed. A perfect artificial riverbed suspended in the sky. Smooth, seamless, silent, waiting. But the structure alone isn't enough, because a river without movement is just a container, and what they're about to install next is the heart of everything. Far below, a massive steel structure is being prepared. At first glance, it looks like a giant box, but in reality, it's something far more complex. This is the caisson, a 7,000-ton chamber designed to hold both water and an entire cargo ship. Moving it is already a challenge, but lifting it? That's where things become almost absurd. Instead of cranes, engineers use a system of strand jacks, machines capable of pulling enormous weight upward, inch by inch, using tensioned steel cables. The caisson is attached, the system engages, and then it begins to rise, slowly, unnaturally, 7,000 tons of solid steel, leaving the ground.
Watching this moment, it almost feels unreal. So much weight, and yet this system lifts it so smoothly, as if gravity has no control at all.
Hour after hour, the ascent continues. No sudden movements, no jerks, just a steady climb toward the top of the tower. Suspended in mid-air, the caisson becomes the most dangerous object on the site, because if anything fails here, there is no recovery. Finally, it reaches the summit, positioned carefully above the hollow core of the tower, the space prepared for it from the very beginning. And then it begins to descend, not falling, but guided downward into its final resting place. A steel heart lowered into a concrete body, locked in forever. Now comes the muscle. Inside the upper levels, massive electric motors are installed, gearboxes the size of rooms, each component engineered to convert raw power into controlled movement. Together, they form a system capable of generating thousands of horsepower, enough to move not just the steel, but water, and everything floating within it. But there's one final piece that changes everything: balance. A massive counterweight is assembled alongside the system, equal in mass but opposite in purpose. When the caisson goes up, the counterweight comes down. When one descends, the other rises. It's a perfect exchange of energy, reducing the load on the motors, making the impossible efficient.
This system doesn't run on power alone. It runs on balance. Without this counterweight, the amount of energy required would be so massive, the project simply wouldn't be practical.
Cables, miles of them, are threaded through pulleys, connecting every part of the system into a single synchronized machine. And then, with one final connection, it becomes alive. For the first time, the system powers on. There's no dramatic explosion, no loud activation, just a quiet hum as energy begins to flow through steel, through cables, through structure. The caisson moves slightly, a test, a single meter up, then down. Everything holds. The machine is ready, but it still lacks one thing: the river. The command is given. Water begins to flow into the channel. At first, it's slow, controlled, almost cautious. But as the level rises, the true weight begins to reveal itself. Thousands, then millions of liters of water filling the sky bridge, every joint, every weld, every seal, now under real pressure. And yet, nothing fails. The structure holds perfectly. What was once empty steel is now a living river suspended above the valley. Then comes the final moment. A cargo ship approaches, not to cross a bridge, but to enter a machine. It glides into the caisson, surrounded by concrete walls. Gates close behind it, water stabilizes, sensors activate, calculations finalize, total mass locked in.
This is the moment where theory ends and reality begins. Now the system will prove that it wasn't just built, it actually works.
The command is given. Silently, the motors engage, and the impossible begins. The caisson rises. A ship carrying thousands of tons of cargo head begins to lift into the sky. Not fast, not dramatic, but steady, controlled, relentless. The valley drops away beneath it. The mountain, no longer an obstacle, but a path. At the top, the gates open. Ahead, a calm stretch of water suspended in midair. The ship moves forward, leaving the ground behind, sailing into the sky. And just like that, the rules have changed. This isn't just a canal. This is a machine that bends geography itself. A system where mountains are no longer barriers. They are just another level to climb.